हम समझेंगे कि व्हाट इज रिलेटिव एटॉमिक मास। तो हम जो है क्या लर्न किए हैं, मास नंबर, atomic number, right? And we also learned what is isotopes and isotones. Okay, but whenever you pick any element, if you look at its mass unit, atomic mass unit or relative atomic mass, it is never a whole number. AMU is never a whole number. Okay, why the atomic mass unit is never a whole number? Because we have a mixture of isotopes of an element in nature. Isotopes mixture of an element in nature, right? So atoms are very small, right? We have a nucleus and we have an electron all around. So these are very so nucleus has neutrons and protons, which contributes to the mass of an atom, and electrons are massless. Like if you look at the neutron and proton mass, which has been determined compared to electron, so it is almost 2000 times the electron mass, right? So it is 2000 times electron mass. So atoms weight comes from nucleus, okay, which is contributed by neutron and protons. So what happens that some of the elements has more of neutron than the its counterpart, okay. The protons numbers are same, so that mixture gives you a different atomic number, okay, a different atomic mass. But measuring a single atom mass is very difficult. So what you can take, it can take a lot of mass, lot of atoms in fact, okay. So you take a lot of atoms, you take lot of atoms, 1 atom, 2 atom, 3, 4, 5, 6, 7, 8, 9, 10, like that. So you take 6.023 into 10 to the power 23 atoms and measure this mass. So and measure this mass, it will give you a significant amount, which is measurable amount, right? But how it is decided? It was done experimentally that this many number, this was given by Avogadro. So this many number is called 1 mole, and this weight is called atomic mass unit. But in scientifically how it is done, so you take an atom, which has a neutron, you have electron, this electron is ripped off, so it becomes positively charged. This is accelerated by ionization, and there is a positive charge, so it becomes positively charged atoms, which will be accelerated by using positively charged electrodes. So it accelerates, and you apply a magnetic field, it will deviate. So if it is heavier atom, it will deflect sooner, okay. If it is lighter metal, it will go further away. So that relative value gives you the relative atomic mass. So what has been given is that pure carbon was taken, carbon 12 was taken, and this was passed through. So whatever the distance it covered and where it deflected, 1/12 of that distance, okay, value was given the 1 atomic mass unit, okay. So 1/12 of this carbon 12, which was an accelerated in a tube in a mass spectrometry. So here is an element, heated element, which produces high energy electrons, which knocks off the electrons of the carbon atom and becomes positively charged. Then it is accelerated using positively charged electrodes. Once it passes through it, it is deflected by magnetic field, and the recorder detects how much it has gone deviated. So that gives you the value of the mass of an atom, okay. So whatever the value was given, It was given C12, carbon 12 atom. So 112 mass, atomic mass unit. Okay, so 1/12 of this mass is called 1 atomic mass unit. So compared to that, compared to one sorry compared to 1/12 of the C12, how much heavier these other atoms of another element, say chlorine or say neon or we say hydrogen or say oxygen. So that will give you the atomic mass unit of that element. Okay, so what we know, that relative atomic mass of chlorine 35.5. So this we have to understand why the chlorine, if you know, chlorine has two isotopes. We have chlorine 35, now chlorine 37. So it has 17 electrons, 18 protons, neutrons, 18 neutrons and 17 protons. This has 17 protons and 20 neutrons. So these two are in different mixtures, so they will deflect in a different ranges, different way. So average of that will give you the relative atomic mass of chlorine in the nature. So that is why chlorine has a number 35.5. Same way neon also is a mixture of isotopes and they are abundant in different percentages. So that is why the relative atomic mass of neon is 20.9. So it is never a whole number if we look at the atomic mass unit. So in real life, how the spectrometer looks. So here is a depiction of the spectrophotometer, mass spectrophotometer, which where you can have a filament, high energy filament, which ionizes up atom, knocks its electrons, makes it positively charged. That positively charged electrons, positively charged atoms could be accelerated through positively charged electrodes, and this is passed through, and this gets deflected by the strong magnetic field, and that the deflection is measured by computer. So how much it has deflected gives you an idea of the how heavy or light that atomic mass unit is. So carbon 12 was chosen as a standard, and the atom was passed through it, and how much is deflected is given a 12 atomic mass unit. So 1/12 of this is 12 atomic mass unit. Okay, 1/12 of this is 1 atomic mass unit. So compared to that, what will be the atomic mass unit will be of any elements is calculated. So questions, say chlorine 35 has abundance of 75.8% and chlorine 37 has relative abundance of 24.2. So the relative atomic mass will be how much? So how much we are going to calculate? So 35 multiplied by 75.8 plus 37 multiplied by 24.2 divided by 100. So this will give you the 35.5. That will be the atomic mass unit will be there. So almost 24%, and this is almost 76% in percentage. Why? So let's make the math simple. 35 multiplied by 76 plus 37 multiplied by 24. So these two together. So let's do the math. I will just do it by calculator. So let's look at that. 2660 plus this is rough calculation, not the accurate one, but for the understanding. So this will give you 888. Okay, if we simplify this percentage, and this is all together will come 8. So 35.48 divided by 100. So 35.48. This is the atomic mass unit, but in the exact calculation it will come 35.5. So here is another one where, for example, neon 20 is 99.9%. Okay, and neon 22 is 8.8%, and very small percentage neon 21 is 0.3%. So if you so it will mass will come something around 20.9 if you do the maths. Okay, so let's look at the some isotope questions. What will be the neutron numbers in these for neon? Neutron numbers in neon? So neon has how many electrons? Helium, lithium, helium, neon atoms are there. 10 protons are there, 10 neutrons are there. This will have 11 neutrons, and this will have 12 neutrons for neon. So that is how you will know. So neon atomic number is 10, and then same way argon atomic number is 18. So thanks for the attention, students. You can help me with this channel by subscribing and support me. Thank you. Thanks a lot.